All right, good morning, mathematicians. This video is going to walk you through lesson 2.4, where we're connecting tables, graphs, and equations. Yes, I know you guys love hearing those words, tables, graphs, and equations. We're still making the connections between all three of them, okay? So in this lesson today, you will see how the three of them are connected because you can use one, so you can use one to get to another. For example, we're gonna start from a table, then we're gonna go into a graph. Or actually, we're gonna start from an equation, making a table, and then making a graph of that equation. Our focus question are, how are solutions of an equation of the form y equals b plus mx? We also talked about y equals mx plus b. They mean the same thing, but they're written in different ways. How are the solutions of an equation in this form related to the graph and the table for the same relationship? Okay, so I'm going to walk you guys through plan 1, but then I think you guys can take over at plan 2 and plan 3. Okay, so they give us an equation here, which is y equals 5x minus 3. Okay, I'm going to write that over here, so that way I have it fresh in my brain. They give us all of these x values, and what we're going to do is we're going to plug these x values into the equation, and then that's going to give us a corresponding y value. Okay, so let's take a look. My first x value is -5, so I'm going to plug in -5 for x. Okay, so it's going to bring back all of those multiplication rules for negative numbers. 5 times -5 is -25, and then -25 minus 3 is -28. So the corresponding y value for -5 is -28. And there we go. Let's go ahead and plug in a -4. 5 times -4, and you're probably asking me, or you're probably wondering, do I have to write all of this down? Yes, you do. Yes, guys, the short answer is yes, but the more you write down, the more you'll be able to catch your mistakes when they happen. Okay, so this is -20 minus 3, so that's at -23. You're also probably wondering, like, how am I going to graph those? My graph doesn't even go all the way to -23. Well, in that case, I will agree with you. So I would suggest graphing what you can. Make sure your graph goes all the way through the provided graph, okay? So there's -3, and then -3. Sorry, lost my train of thought for a second. -15 minus 3 is -18. Okay. Now you're probably thinking that, hey, this equation is this equation represents a linear relationship because it has this piece right here. It has some sort of number that's a coefficient of our independent variable, right? And we've talked about why that is a linear relationship. So at this point, you're probably saying, well, every time my x value increases by 1, well, what's happening to my y values? Let's take a look. -28 to -23. Well, I added 5. Let's double check the next one. -23 to -18. I added another 5. So at this point, you can probably do something like this, right? You know that we're adding 5 every single time, so -18 plus 5 gives me -13, and then you can continue the pattern just like this. So that way it saves you some time, so you don't have to constantly be doing this stuff here. But again, you guys, I would write out as much work as you can, make sure that you have the correct pattern, and then you can start using these shortcuts, okay? So if we add another 5, we're at -3. We add another 5 to get to +2. Add another 5, we're at 7. Add another 5, we are at 12. Then we are at 17, and then we are at 22. So we are adding 5 every single time. Okay, and let's see what we can graph. I can graph, well, -5, it's way up there. -28, it's way up there. Because my graph only goes to 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is 13 right here. and that's on the positive side. The negative side only goes to -5. So we can't really graph anything from below 0. So why don't we just go ahead and start with 0? So when x is 0, y is equal to -3, also known as the y-intercept. So our y-intercept is at 0, -3. We go to when x equals 1, y is 2, which is right there. When x is 2, y is 7. So there's 5, 6, and 7. 3, y is 12, 7, 8, 9, 10, 11, 12. There we go. I think that's all we can graph on this graph. So what we're going to do is we're going to connect our lines using a ruler or a protractor, please. Make sure it goes all the way up and extends a little bit out of the graph. And then we'll do the same going in the negative direction. There we go. That looks pretty good. Okay, and there is our line. Okay, so you guys have 2 more to do. Okay, plan 2 and plan 3. So remember, plug in your x values into your equation, and then out will come a corresponding y value. Then you're going to plot your coordinates just like we did here. So all of these become coordinates, right? Coordinate pairs, or ordered pairs, I should say. And then you can graph all of them, or graph what you can. I want to walk you guys through maybe the first 3 x values here in plan 2, because you guys might get a little confused with our equation. So our equation is this: it's -x plus 6, or I can read that as the opposite of x plus 6. So when I plug in -5 for x, it'll kind of look like this: -5 plus 6. Think of this as -1 times -5, and then you can move forward. So -1 times 5 is 5, plus 6 is 11. So there's my first point, -5, 11. Let's try the next one. -4, I'm plugging it in for x, so I'm doing -4 plus 6. -1 times -4 gives me +4, so 4 plus 6 is 10. And there we go. I'm going to do one more. I'm going to do 5 here. Okay, when I plug in 5 for x, I have -5, right? That negative x is very important, okay? So -5 plus 6, and this is 1. Okay, so there we go. I think that's enough information to get you guys started. So go ahead, finish plan 2 and plan 3, and then we'll talk about these questions here on page 34. All right, folks, so hopefully you finished your plan 2 and plan 3. Here are my tables and my graphs. So plan 2 looks like this. It's here in orange. Okay, and then plan 3 looks a little, it's probably a little tricky for you guys. You guys are probably wondering, what's happening here? There's no x. I can't plug in x anywhere. Well, the way I like to read this equation, well, it's y equals 2, but if you think about it, for every x value that you plug in, what is y equal to? So, for example, if you were to plug in -5 into this equation, which there isn't a way for you to, y is equal to -2. Or positive 2, excuse me. If you were to plug in -4 into this equation, y is equal to 2. So for every x value that we plug in, y is always equal to 2. So that's what this equation is telling us, and it turns out to be like this. We got a nice horizontal line here, okay? All right, so let's go ahead and talk about these questions here. Which of the graphs contain the point 2, 4? And how did you know that the point was on the graph you chose?
I accidentally took one of your calculators. So
That's where it went.
Yeah, number 24. I accidentally took your calculators, I'm sorry.
That's all right, Jude.
I just opened my planner, and a calculator.
And a calculator fell out? Awesome. Well, I'm just glad you found it and you're returning it, so thank you.
Yeah, I don't want this calculator. Please take it back.
Thank you, Jude.
You're welcome.
right, I'll see you tomorrow.
Okay.
So if you take a look at our graphs, we just got to figure out, well, which graph, or which line, I should say, passes through the point 2, 4. So taking a look here, 2, 4 on plan 1, 1, 2, 3, 4 is right there. That's not on our line, so we're going to say plan 1 is a nope. Let's look at 2, 4, which is right here. So plan 2 definitely has 2, 4. And then plan 3, well, 2, 4 is 1, 2, 3, 4 is right here. So definitely not plan 3. So the graph that contains the point 2, 4 is plan 2. And how did you know? Well, we just looked at the graph. We plotted the point 2, 4, and whatever line passed through that contained the point. So I'll say we plotted 2, 4, and whichever line passed through contained the point. Okay, how do coordinates 2, 4 relate to the equation of the line, right? So let's take a look at the equation that we were given. I believe it was negative x plus 6. Yeah. Y is equal to negative x plus 6. Let's take a look at how 2, 4 relates to this equation. So remember, we're getting into the habit of plugging in values into the equation, right? Because we're looking for special coordinates. We're looking for special ordered pairs. And you might already be thinking of the word that I'm thinking of, but I don't want to spoil it here. So my x value is 2, my y value is 4, so I'm going to go ahead and I'm going to substitute those in, 4 for y, and then I'm plugging in 2 for x. So negative 2 plus 6 gives me 4. When I plugged in this ordered pair, 2, 4, it made the equation true. What do we call an ordered pair that makes an equation true? Well, you might remember that it is a solution to the equation. So 2, 4 is a solution to the equation. And we're being very specific here. Y equals negative x plus 6. Okay, how do coordinates 2, 4 relate to the corresponding table of data? Well, if you plug in 2, what happens? Well, out comes 4, right? You do the math and out comes 4. So in the table, you plug in 2, and out comes 4. Okay, describe how a point on a graph is related to a table and an equation that represents the same relationship. Well, we already said it in the previous question, right? A point on the graph is related to the equation because it is a solution. So a point on the graph is a solution. Okay, and if your point is a solution, do you think that point is also going to be included in the table? Hopefully you said yes. So I'll say this point will also be included in our table. Okay, there we go. All right, now I want you guys to take a moment, pause the video, okay, try and answer these questions on your own. How can you use a table, graph, or an equation that represents the relationship y equals 5x minus 3 to find the value of y when x equals 7, or to find the value of x when y equals 23? Okay, so make sure you're answering the entire question. Make sure you're answering how do you use a table to find this, how do you use a graph, and how do you use an equation? Okay, those are the things that I need to see. All right, so go ahead, pause the video, and try it. All right, hopefully you pause the video. Usually the equation kind of comes naturally to me. So I have my equation y equals 5x minus 3, and I know that x is equal to 7. So immediately my brain wants to plug in 7 into this equation. So I can go y equals 5 times 7 minus 3. So that's 35 minus 3. So then y equals 33. So here I have more of a show your work rather than explain here, but in words I am plugging in 7 for x into my equation and then getting a corresponding y value. Okay. In the graph, if you were to graph this line, right? If you were to graph this line, here, let's do this. I want to show you guys. If you were to graph this line, say you had a graphing calculator with you. You were to graph this line, y equals 5x, what was it, plus 3? Let me double check. Y equals 5x minus 3, excuse me, minus 3. It's a not very different, but slightly different, but the difference is important. Okay, so how are we going to find when x equals 7 here? Well, if you take a look, 7 is right in between 6 and 8 at this point right here. Right, so if I find the 7 on my x-axis, I go all the way up to my line, and then the corresponding y value is at 32. Okay, and that's how we're going to use a graph here. So find x equals 7 on the graph, or on the x-axis. Then you're going to go up to your line, go up to the line, and find the y coordinate. And find the y coordinate. And there we go. Okay, and then of course in a table, right, we're creating something like this, where we plug in x values and out comes y values. So, you know, in your table, you might want to include x equals 7, plug it into the equation, and then out comes your y value. So we'll say plug in 7 for x and solve for y. And there we go. I'm going to leave B up to you guys, okay? You guys should be able to answer this now that you have an idea of how we answered A, okay? All right, and please don't forget to submit a picture of your focus question to my Connect, please. Okay, that's part of your assignments for today. All right. Well, happy studying.